All right, so we're going to talk about long division and synthetic division. Now, if you've taken the previous math course, 102, intermediate algebra, you should have been exposed to long division. And before we actually get into this, long division, I'm not going to say it's a nightmare, but it's a kind of involved process. We're also going to look at synthetic division. And synthetic division, just like long division, it allows you to divide rational expressions. Okay? So before we look at either long division or synthetic division, I want to talk about the degree of a term. Okay, because you're going to hear me mention a degree. So I just want to just clarify what a degree is. So a degree of a term is nothing more than the value of the exponent on the variable. Okay. All right, so the degree is nothing more than the value of the exponent on a variable. So I'm going to list out a chart, and in this chart on one column I'm going to put the term, and on the other column we're going to figure what's the degree from the given term. All right, so I'm just randomly writing some terms. So we're going to take 3x squared negative 4x, let's say 1/5 x cubed, and 3. All right, so we have 4 terms: 3x squared, negative 4x, 1/5 x cubed, and 3x, and we want to determine the degree for every term. Now, when we talk about the degree of the term, right, so for example, if we look at 3x squared, I'm only looking at the exponent. So for 3x squared, 3 would actually be my coefficient. My variable is x, and x is raised to the second power, so this term has a degree of 2. Or it's a second degree term when you hear me say that. If we look at the next term, negative 4x, keep in mind that the definition of a degree is the value of the exponent on the variable. So in negative 4x, my variable is x. X is understood to be raised to the first power. So the degree for that term is 1. Right? That's a first degree term. Okay, so it doesn't matter about the coefficient, if it's negative or positive. We mainly locate the variable. Then we locate the exponent on the variable, and that will give us a degree for the term. Okay. So for 1/5 x cubed, x is the variable. The value of the exponent on the variable is 3, so that's a third degree term. And then if you look at the very last number, that's a constant, right? Notice that it does not have a variable, okay, but it's actually an understood variable. All right, so before we actually determine the degree of a constant, it's just by a rule, the degree of any constant. There's something called a zero exponent rule, and it says that any quantity raised to the 0 power is 1. Right? So just by knowing that zero exponent fact, I have 3. I could attach a variable and an exponent, right? Because x to the 0 is nothing more than 1, and then 3 times 1 is still 3. All right, so just given this fact of a zero exponent, we can determine that the degree of any constant is zero. All right, and then I'll just put one more. Let's say we have -2. If -2 was your term, the degree for -2 would also be 0. Okay. Now you'll see in a second why these degrees are important. All right, next we have the degree of a polynomial. Okay, so we talked about the degree of an individual term. The degree of an individual term would just be the value of the exponent on that variable. For the degree of a polynomial, the degree of the polynomial would be the largest degree let me rephrase it. It takes the degree of the largest term. Okay, so it takes a degree of the I should say largest exponent. All right, so it takes a degree of the largest exponent. So here again, I'm just going to put another chart. On one side, I'm going to put polynomial. And on the other side, we're going to put the degree, okay, for the polynomial. So remember that just the definition of a polynomial can be a monomial, and a monomial is just an expression with one term, as we looked at before. You could have a binomial, and a binomial is a polynomial with two terms. So an example of a binomial would be 2x squared plus 4x. A trinomial would be a polynomial with three terms. So -5x to the fourth power plus 2x squared plus 1 would be considered a trinomial. All right, so we'll just take these two. So if we look at this first polynomial, 3x squared plus 4x, notice that we have two terms. If I look at my first term, which is 3, that term has a degree of 2. If I look at my second term, 4x, it has a degree of 1. The largest degree term is 2, so the degree of that polynomial is 2. If I look at my second polynomial, -5x to the fourth plus 2x squared plus 1, right? Notice that my largest degree term is x to the fourth, so that polynomial would have a degree of 4. All right, so the last thing I want to talk about is descending order. And for descending order, we have the terms of our polynomial in order from largest to smallest. So once again, for descending order, we have the terms are ordered from largest to smallest degree. So here's just an example of a polynomial that is in descending order. negative 3x cubed plus 2x squared plus 4x minus 1. So notice for this polynomial, I have a cube term, negative 3x squared. I have a second degree term, negative 2x. I have a first degree term, which is 1. And then I have the constant on the end, which is 0. As we proceed to look at long division, you must make sure that that your divisor and your dividend are in descending order. All right. So let's look at an example. So we're going to use long division. And we're going to do a few of these. So we have 4x squared plus 18x minus 12 divided by 4x minus 2. So now in some problems, you're going to see them written out horizontally. In other problems, you may see them written out vertically. Okay. All right, so in either case, we have a divisor, which is the denominator, and we have a dividend. So the numerator is the dividend, and the denominator is the divisor. When you set up long division, you have to make sure that both your divisor and your dividend are in descending order. If you're missing any terms, you would have to add a filler term. Okay, so we're going to look at all different situations. All right, so my divisor is 4x minus 2. And the dividend is 4x squared. So I have my second degree term plus 18x, which is my first degree term, minus 12, which is the 0 degree, right? Because the constants have a degree of 0. All right, so now we're going to multiply. So for my divisor, I have 4x minus 2. Since my divisor contains 2 terms, I'm only going to concentrate on the first 2 terms of the dividend. So here's what we want to do. We want to figure out what we can multiply 4x minus 2 by to give us 4x squared plus 18x if possible. So I want to concentrate on my first terms. I want to concentrate on 4x and 4x squared. Now we're going to always make the first term match up. Right? Whatever happens with the second or third terms, it just happens, and we'll take care of that on the next iteration of division. So what would you need to multiply 4x by to get 4x squared? Right? You would multiply by x. Since I have 2 terms in my divisor, I'm going to place x above the second term in the dividend, right? Because I'm going to distribute. X times 4x, that gives us 4x squared. X times negative 2 gives us negative 2x. Right, so just to kind of review this, I concentrated on my first terms, 4x and 4x squared. Right, so I had to figure out 4x times what would give us 4x squared. Right, so we figured that 4x times x is 4x squared. Right, so we use the multiplier x. Right. So then we distributed x. X times 4x is 4x squared. X times negative 2 is negative 2x. From this point, we must change the signs. Right? So here's what I mean by changing the signs. And this is one of the most important parts. And it's the most overlooked part if you're dealing with rational expressions. So let's say we have 4, and we have let's say 112. Okay. So we would have to figure out what we need to multiply, right? So 4 times, before I can go to 11, how many times without going over? 2, right? So 4 times 2 is 8. That's basically what we just did up here. So in basic arithmetic, once we figure out what we can multiply by without going over, the next thing to do is change the sign, right? So I must make sure I follow the same rules when I'm using long division. So I must change the signs. So this negative, excuse me, so this 4x becomes, and I'm going to try to change the color, negative 4x. This negative 2x becomes a positive 2x. So you must change the sign for every term. All right, so notice what happens when we do that. The first terms, they should always cancel. Right, 4x squared minus 4x squared is 0. And next, I'm going to combine my next two terms. So 18x plus 2x is 20x. Right. And since I have two terms in the divisor, I must maintain two terms. So I'm going to bring down minus 12. All right, so I'm going to repeat the process from the earlier step. I'm going to concentrate on my first terms. I have 4x and 20x. 4x times what value will give us 20x? 5. So we're going to multiply by 5. We're going to distribute 5. So 5 times 4x is 20x. 5 times negative 2. So remember your rules for signs. A positive times a negative is a negative. So we have negative 10 or minus 10. And from this step, what must we be mindful to do? We have to change the sign. So 20x becomes negative 20x. And 10 becomes, well, negative 10, excuse me, becomes positive 10. All right, so now we can combine. So the 20x, that's going to cancel, and that should always happen. Negative 12x plus 10x is negative. Give me a second. Okay, I should still be recording. Hopefully I am. All right, so negative 12 plus 10 is negative 2, and negative 2 is our remainder. All right, so I guess if I go back, try a little example over here, well, that's not going to work. All right, so I'm simply going to put my remainder over my divisor. So my remainder is negative 2 over 4x minus 2. Long division problem. Okay. Because I'm actually looking at the homework. So if it asks for long division, you want to use long division. If it asks for synthetic division, you want to use synthetic division. All right, so here is a long division problem. And then we'll do another synthetic division problem. Figure that out. Okay, we have 6x cubed minus 3x squared plus 1 divided by x squared minus 1. All right, and we're going to use long division. So our divisor is x squared minus 1, and the dividend is 6x cubed minus 3x squared plus 1. Now we got to make sure that everything is in descending order. So my divisor, notice I have a squared degree term. I don't have a first degree term, so I'm going to have to put in a filler term. So I'm going to have to put in a filler x to the first power minus 1. Right, so I have a second degree term, a first degree term, and a 0 degree term. I have to check the same thing for the dividend. So I have a third degree term, I have a second degree term, I'm missing a first degree term, so I'm going to put in a filler term plus 1. Right, so I have descending order for both the divisor and the dividend. So we have three terms in the divisor, right? So here again, we're going to concentrate on those first terms. So x squared times what will give us 6x cubed? I believe that's going to be a 6x, right? 6x times, 6x squared times x gives us 6x cubed. Yeah, x squared times 6x gives us 6x cubed. So we're going to multiply by 6x. Since we have three terms in the divisor, I'm going to put 6x over the third term in the dividend. So now we're going to multiply. So 6x times x is 6x cubed. 6x times 0x is 0x squared. And 6x times -1 is -6x. So the next thing we need to do is change the signs. So 6x cubed becomes -6x cubed. Now 0 is neither negative nor positive, but I'm just going to change it to negative just to be consistent. -6x becomes positive 6x. So that's a step that's often overlooked when you use long division. So now we're just going to combine. So the 6x cubes will cancel. -3x squared minus 0x squared is -3x squared. 0x plus 6x is 6x. And since I have three terms in the divisor, I must maintain three terms. So I'm going to bring down +1. Okay, so now I'm going to concentrate again on the first terms, x squared and -3x. So x squared times what quantity would give us -3x squared? Right, I believe that's going to be -3. And now we're going to distribute -3. Right, so -3 times x squared is -3x squared. -3 times 0x is 0x. And then -3 times -1 is +3. So the next thing we're going to do is change the signs. So -3x becomes positive. Right, 0x becomes positive. +3 becomes -3. And then we're going to simplify. So the 3x squares will cancel. 6x plus 0x is 6x. 1 minus 3 is -2, and that is our remainder. Right. So I'm going to take the remainder, which is 6x minus 2. And since the sign is positive, I'm just going to denote the remainder with either positive or negative based on the sign. So I have plus 6x minus 2 over x squared minus 1. And this is our quotient. Right, and I'm going to find one more that uses synthetic division. Okay, here's one. This is similar to number 6. Use synthetic division. X to the 4th minus 15 divided by x plus 2. All right, so remember the steps. Okay. All right, so we're actually using synthetic division, so we're going to use synthetic division. So the first step, set the denominator equal to 0. And solve. So the denominator is x plus 2. I'm going to set that equal to 0. And if we solve for x, we have -2. So -2 is our divisor. Next, we're going to write out the coefficients for the dividend. But we have to make sure if we're missing any degree terms, we got to put in filler terms. So we have an x to the 4th. That has a coefficient of 1. We don't have an x to the 3rd term. May just have to turn this off. Okay, I guess I have to turn it off. Okay. All right, so we don't have a 3rd degree term, so I'm going to put in filler 0. We don't have an x squared term, so I'm going to put in a filler 0. We don't have an x term, so that's another filler 0. And then we have the constant on the end, which is minus 15. So if you're missing any degree terms, you must put in a filler 0. All right, so the first number always comes down, and it's a plus. All right, so now it's a matter of multiplying and adding. All right, so negative 2 times 1 is negative 2. Zero minus 2 is negative 2. Negative 2 times negative 2 is positive 4. Zero plus 4 is 4. Negative 2 times 4 is negative 8. Zero plus a negative 8 is negative 8. Negative 2 times negative 8 is positive 16. Negative 15 plus 16 is 1, which is our remainder. All right. So we found the divisor. We listed out the coefficients for the dividend, adding any filler terms, right? Then we use a process. We brought the first number down. We use a process of multiplying and adding. Notice that we started with a 4th degree term. Right? So for our quotient, it's reduced by 1 degree. So this would be x cubed. So we have 1x cubed minus 2x squared plus 4x minus 8. And then we have a remainder of positive 1. So we're going to put the remainder over the divisor, which is x plus 2. Right, and this is our quotient.